Question 16 is asking us to find the magnitude of this vector. So for magnitude, what we're going to do is we're going to use the formula square root of -4 square plus 5 square. So that's going to be 16 plus 5, which is going to give us 16 plus 25, sorry. 16 plus 25, which is going to be root of 41. That is your magnitude. Then part B is saying that the diagram shows a triangle OAC. A is the midpoint of the straight line OAB, which means if OA is X, AB would also X. And OC is Y, OX is A. Find CB in terms of X and Y. So to reach CB, if I draw a line over here, this is what we're trying to find, this vector. So let's say I start my journey from B. I go from B to A, then from A to O, and then from O to C to reach CB. Yeah, that would be BC. Wait, sorry, it's gonna be CO plus OA plus AB. Yeah, that's gonna be CB. So CO would be, since we're changing the direction, since OC is Y, so CO would be negative Y. The negative sign shows the change in direction. OA is X, AB is X, so that means negative Y plus 2X, which can be written as 2X minus Y as well. Then question 17 is asking us to simplify this. So we know that 9 square is 81 and 3 square is 9. So if we replace 9 with 3 square whole square, that's going to be 3 to the power of 4. So replace 81 in the brackets with 3 to the power of 4. So 3 to the power of 4 times x to the power of 12, 4 power 3 over 4. So when we have a power outside the bracket and we have power inside the bracket, what we can do is we can multiply the powers inside the bracket with those outside, which means 3 to the power of 4 times 3 over 4 times x to the power of 12 times 3 over 4. That's going to be 3 cubed, and x to the power of 9. 3 cubed is 27, so 27 x to the power of 9 is your answer. Then question 18 is saying that the diagram shows the position of 3 towns U, V, and W. U is due west of V, and the angle UVW is 125. This angle is 125 degrees. Calculate the bearing of U from W. So it says of U from W, so we draw a compass at W. And our bearing is basically going to be this entire angle. So since we have one complete pair of length and angle, by complete pair I mean that we have an angle and we have the opposite length, which is 62.4. You can easily use sine rule over here to find this angle. I'm going to do 62.4 over sine 125 equals to 27.3 over sine of W, not W, I'm going to say UWV. Yeah. So let's rearrange it. And I'm going to make this the subject. And that leaves me with 27.3 times sine 125 over 62.4. Log the entire thing in the calculator. So 27.3 times sine 125 divided by 62.4. And then we do sine inverse of this. The sine inverse of 0.35837. That gives us 21. So now we know that this value is 21. And we need this entire thing. So what I'm going to do is I'm going to find this angle. So angle U is going to be 180 minus 125 minus 21, which is going to give us 34. So if this is 34 and this is a straight line, that means if I draw a line over here, that is going to be 90 minus 34, that's 56. So if you remember, in parallel lines, alternate angles are equal. I'm going to choose a different color. If this is 21, this entire angle is 56. And to get this small angle over here, actually we don't need to find the small angle. We can just directly do for the bearing now. It's going to be 180 plus 56. Yep. So 180 plus 56 is going to give us 236. Anyways, that is your bearing. Then question 19. On the diagram, sketch the graph of y equals to cos x from 0 to 360. So what you need to remember is that in a cos graph, your maximum value is 1 and your minimum value is -1. You start from your maximum value like this, and your minimum value is at 180. Your intersection points are at 90 and 270. Excuse me. And say solve the equation 5 cos x plus 3 equals to 0. So for that, this is your minimum. So 5 cos x plus 3 equals to 0. Going to make cos x the subject, so it's going to be -3 over 5. Then we take cos inverse of that. So that gives us cos inverse of -3. 5 by 5 is 126.9 degrees. So now 126.9 degrees is basically over here. If we find the difference of that, +40 +45, 135. 135 is in the middle of 126. Somewhere over here. Basically, your 3 by 5 is 0.6. Since negative 0.6, negative 0.5 would be over here, so negative 0.6. Slightly rough, but one. This is your negative 0.5. So your negative 0.6. You're gonna get these two values. Yeah, we're going to get these two values. The first value is 126.9 degrees, which we already have. Second value would be, now we know that cos is negative in the first and the second and the third. So this is 126.9, which means if we do 180 minus 126.9, that is 53.1 over here. And then this is also 126.9. So we have to figure out the third angle, which is between 180 and 270, which means what we will do is we will add 53.1 to 180. So 53.1 plus 180 is going to be 233.1 degrees. So these are your two values of x. Yeah. Then question 20 is saying complete the following table. So what you'll do is you'll just substitute the value of negative 0.5 and 0.5 in your equation like this, and find the corresponding value of y, which in the first case is going to be 0.75, and in the second case it's going to be negative 1.25. Yep. Part B says on the grid, draw the graph of y equals to 3x squared minus 2x minus 1 for negative 1 to 1.5. So let me just write these on the side so that we have our coordinates and we don't have to keep scrolling up and down. And 1, 0, and 1.5, 2.75. Okay, we're going to erase this. And now we can easily scroll up. Okay. So negative 1 and 4 is going to be this one. Negative 0.5 and 0.75 is going to be, wow, this graph is tiny. 1, 2, 3, 4, 5, 8. So it is 9, 8. That's gonna be this. Then 0, negative 1 is this. And 0.5, negative 1.25. Okay, so it's gonna be this. And 1 0 is this. And 1.5 and 2.75. That's 2. That's 3, so 9. This. And let's hope that these are the accurate values because this graph is really tiny. Okay, so that's now the difficult part. Drawing this freehand on the touchpad. Oops. Great, so that's gonna take ages. Okay, we have something which looks remotely like a quadratic curve. Okay. Next part, it's asking us to, we've done that. Drawing a suitable straight line, solve the equation 3x squared minus 4x minus 2. Okay, 3x squared minus 4x minus 2 for the limit of -1 to -1.5. Okay, so here's the trick. For this, we already know our equation was, the original equation is y equals to, wait, let me just fix that. Y equals to 3x squared minus 2x minus 1. So they have given us the equation to solve for, which is 3x squared minus 4x minus 2 equals to 0. Which means we first have to put this equal to a straight line, which is indicated in the question. So in order to turn 3x squared minus 2x minus 1 into 3x squared minus 4x minus 2, it means that on the left hand side, y should equal to negative 2x minus 1. So if it equals to negative 2x minus 1 and equals to 3x squared minus 2x minus 1, when you move it to the left hand side, what happens is that, sorry, not negative, positive over here. Yeah, so when you move to the left hand side, the right hand side, what happens is that it becomes 3x squared minus 4x minus 2, which is exactly what the question is asking. That means this is a line which we have to sketch. So to sketch the line, what we're going to do is, I'm going to first remove these points over here. So our line is y equals to 2x plus 1. And we have the limit from -1 to 1.5 for x. So let's just pick like basic values. If we put x equals to -1, so that's going to be y equals to 2 times -1 plus 1, which is going to give us -2 plus 1, is y equals to -1. So one point is -1, -1. I'm going to use a different color for this. -1, -1. So that's over here. And now let's pick another point. Is, let's say we pick, let's go for whole numbers, like no need to go for like decimals. So if we pick x equals to 1, let's say. That's going to be y equals to 2 times 1 plus 1, which is going to be 2 plus 1, which is 3. So 1, 3 in color. It is accurate. I hope that's correct. So now I'm just going to connect this from over here. And what we get is this point over here, which is x equals to 0.45. 3.4 or something, 0.45, yeah. 2.4 to 0.545, something from this. That would be your solution. Then a curve has an equation. The curve has an equation y equals to x cubed minus 12x. Find the gradient of the curve at the point 1, negative 11. When you have a curve and they ask you to find the gradient, you differentiate it. Differentiate y with respect to x. When you differentiate, what you do is whatever the variable you're differentiating it with respect to, you bring the power of the variable down. It's going to be 3x. And then you subtract 1 from the power, so 3 minus 1 equals to, over here, since x has a power of 1, so when you bring it down, it's going to be as it is. So if you want to skip right, that's also fine. Times 12. And over here, it's going to be 1 minus 1 again. So that's going to be 3x squared minus 12. X to the power of 0, and anything to the power of 0 is equal to 1. So now you can easily skip like these two steps and just do it directly. But like for your understanding, I'm showing you like how it becomes 0 and how like this one is coming down and all of that. So 3x squared minus 12 is your gradient, the equation of the gradient. Now to find the value of the gradient, what we're going to do is we're going to substitute x equals to 1 in this. So at x equals to 1, dy by dx would be 3 times 1 squared minus 12. It's going to be 3 minus 12, which is negative 9. Negative 9 is your final answer. It says find the coordinates of turning points of the curve. So to find the turning points of the curve, what we do is we substitute the dy by dx with 0. So basically put dy by dx equal to 0, which means 0 equals to 3x squared minus 12. Take 12 to the other side, so it becomes positive 12. Divide that by 3 to make x squared the subject. Square root of 4 plus minus 2 is your x. Now keep in mind, this is just your x value. They've asked us to find the coordinates, which means we have to find the corresponding y value as well. So for that, we will use the original equation, y equals to x cubed minus 12x. So at x equals to 2, we have 2 cubed minus 12 times 2, which is going to equal to 2 negative 16. So negative 16 over here. That is the first set of coordinates. And I'm going to put the at x equals to negative 2 over here, since everything is so messy now. Negative 2 cubed minus 12 times negative 2. And that gives us positive 16. So negative 2, positive 16 is our second set of coordinates. These two are your final answers.